Hey everyone, it's time for us to turn our attention to the concept of stub routing. And that means we're going to begin taking a critical look about this part of our network, which is going to be via the DM VPN config. The dynamic multi-point VPN configuration that we have in this topology is going to be the best place for us to entertain this idea of being able to employ a stub area when it comes to EIGRP. Now we're going to have a series of videos on this concept because we're going to find out that we're going to have some capabilities and some granular features that we may want to take a look at. But right now what I want to do is entertain creating this idea of our EIGRP peering relationship across the DM VPN. So what we'll do is we'll go ahead and get that set up and make it operational. Now to do that, what I'm going to do is I'm going to go to R5, since R5 is going to be the hub. So R5 is the hub of my DM VPN configuration, and my DM VPN is phase 1, which means I have no dynamic spoke-to-spoke connectivity. It's not configured to work in this topology. So right now everything must transit the hub. Now, in order to be able to make this operational, what I want to do is I'm going to go ahead and start the config, and we'll just use the same process that we've used before. Config T, router, EIGRP 10, do show IP interface brief, exclude assigned addresses. And what I want to do is I specifically want to run this on my tunnel. So what I'm going to say is network 10, 10, 10, 5, and I'll match it exactly. Do show IP EIGRP interface, and we'll see the tunnel is now participating in EIGRP. Now what I'm going to do is I'm going to go to 19, 20, and 21 and repeat this process. So config T, router, EIGRP 10, network 10, 10, 10, 19, match it exactly. And I want to advertise my loopbacks also. So it's 172.16.0.0. We'll just do that natively. Config T, router, EIGRP 10. And let's say we will do the network 10, 10, 10, 20. And network 172.16.0.0. And lastly, let's do our R21. Now let's do this on R21. Let's go ahead and make this one named. Router EIGRP named address family IPv4 unicast autonomous system 10. And what I'm going to say here is network 10, 10, 10. And we will say 21.0.0.0.0, match it exactly, and network 172.16.0.0, and we should be good to go. So do show IP EIGRP interface, and we see we're running both the tunnel and the loopback. So let's see if we have our neighbor adjacencies. We should have 3 of them. 19, 20, and 21, new adjacency, everything is up. Let's see if we can reach those loopbacks. Ping 172.16, 19, 19, 20, 20, 21, 21, and we have reachability. Now, let's go over to R19, see if we can reach 192 or 172.16.222.222. That's that interface that we configured on R19. Let's see if we can even source it from our own loopback 0 interface. And we can. However, what I want to illustrate is as expected, we should not be able to reach 2020, which we can't. And again, this is because of that split horizon behavior. Shouldn't be anything new to us at this point. All we need to do is disable that process. So what we'll do is we'll turn off split horizon. So config T interface tunnel 0, no IP, split horizon, EIGRP 10. Oh, that's not where I wanted to put it. Wanted to be on 5. Config T, interface tunnel 0, no IP, EIGRP, no IP, split horizon, EIGRP 10. Now I should be able to have reachability between my spokes. And as you can see, I can. Let's say 2121. We'll even source it from our own loopback address, and we should be able to anticipate that everything's going to be good to go in our topology. Now let's do a trace route. Trace route 172.16.20.20, and what we're going to see is we're going to go to the hub, and then we're going to go down. That process is never going to change because this is a phase 1 DMVPN, which means we're not going to have that dynamic spoke-to-spoke connectivity. So from the point of view of EIGRP, we're good to go. Now what I want to do is I'm going to illustrate something by going to this device, by going to R5. Bear with me just one moment. I'm going to go to R5, and what I'm going to do is I'm going to do a debug. I'm going to say debug EIGRP packets terse. Now, doing the EIGRP packets terse is going to allow me to do what I did in the previous video, and that's going to be the fact that I only want to see information associated with updates. Well, excuse me, I want to see everything except my hellos. Now, the point here is this. We have a scenario. I'm going to go over to R1, not R1, I'm going to go over to R22. And what I'm going to do is I'm going to go to interface, LO100, do show run interface LO100, or is it LO0? No, it's 100. I'm going to say shut. Now, the moment I shut that interface down, we know that means I'm going to send queries. Why? I'm sending a query because of the fact that I removed an entry from my routing table. We generated it. So if we look at how that update goes, it's going to go to R2 to R3. From R2, it's going to go to SW1 to R1, and then vice versa. But what we also have to understand is it's also going to go this way. And ultimately, it's going to go this way. Because again, the device is trying to find someone who knows about 172.16.222.0/24. And that query is going to be propagated throughout our entire infrastructure on a hop-by-hop basis. Now, we talked about the importance of the stuck inactive, but the stuck inactive said, well, this is how long I'm going to wait in order to, or before I make a change. So before I shut this down and say, okay, it's just not coming back up. That's the stuck inactive. Now, the other thing that we saw is if we had a feasible distance, or if we had a feasible successor in the topology table, which means that the AD, the advertised distance, is going to be less than the feasible distance of the successor route, then we no longer send that query. We saw that in the previous video. Now, another way that I can stop this process is to go to the devices in question and designate them as being stubs. Stubs lead nowhere, and guess what? R19, R20, and R21 go absolutely nowhere in our infrastructure. But what I want to illustrate here is by turning off a prefix or shutting down an interface on R22, we generated traffic that was sent out on R5. Notice that on R5, notice R5 sent out a query. We'll go all the way up here. And notice R5 sent out a query. Where did it send that query? Well, it sent it out on Fast Ethernet 0.1. That's going to be the interconnection between it and another device. Let's scroll down. See if did it send anything out tunnel 0. There we go. We sent a query out tunnel 0. Now, if R19, R20, and R21 lead nowhere, it's pointless to send them a query. So stubs allow me to do what's referred to as binding my query. So what I'm going to do is I'm going to create a wall dividing this side of my network from this side of my network for the purposes of these queries. In other words, what we're going to find is I'm going to make a configuration on R19, R20, and R21 that is going to designate this area or these particular devices as stubs. So there's no sense to contact me, and the way I'm going to do that is in my hello that I send to R5, I'm going to set my stub flag. And that stub flag says, hey neighbor, I'm not transit for anyone, so don't send me any of these queries. It's also going to affect or give me the ability to be able to affect or impact what particular types of prefixes I can advertise from these stubs, these stub devices. In the context of EIGRP, routers are stub, not areas. There's no concept of areas like there is in OSPF. So let's see what ends up happening here. Now what I'm going to do is I'm going to go to R19, or I'm going to try to go to R19. And I'm going to set this up as a stub. So I'm going to say config T, router, EIGRP 10, and I'm going to say EIGRP stub. Now what I want you to see here is I have a number of options. And look here, we have a leak map. Sure enough, we're going to have a video dedicated on how to use that. But what we need to understand is that we can be selective as to what it is that we want to advertise. I can advertise summary routes. I can advertise static routes, redistributed routes. I can set it up to where I receive nothing except I just receive prefixes. I can also use a leak map to be selective as to which particular prefixes I may want to advertise on a case-by-case basis. So again, we'll look at that further on. But right now what I want to do is look at what happens when we do this configuration using stubs in our topology. Now we already turned R19 into a stub. Now, what I can do is I want to illustrate the fact that this device is indeed functioning as a stub component or as a stub device. And now what I want to do in order to be able to illustrate that, my primary goal here is that I want to execute a command. Actually, no, I haven't even entered it yet. So now it's a stub. So let's go back over to R5. And on R5, here's what I'm going to do. I'm going to say show IP EIGRP neighbors. And I'm going to see here that I have a neighbor relationship with 19, with 20, and with 21 and 20. Notice my Q counts are all zeros. Everything's good to go. And I'm using the same interface to form these adjacencies. Now, the command that I want to illustrate here is going to be show IP EIGRP neighbors detail. Now what I want you to see here is let's take a look at the neighbor 10.10.10.19. What do we see? Well, we see that we are doing stub advertising. And what we see here is that we are automatically going to be advertising connected and summary prefixes. So the moment I went up to R19 and I said EIGRP stub, it took all of the connected interfaces, so my loopbacks, and it takes any summary prefixes that I may be have configured, and it's going to advertise those out its link. And I'm notifying my neighbor R5 of that fact because, again, the stub flag is set. So right now we see here the stub peer advertising is on, and the key element here is that R5 now knows that we want to suppress queries going towards that particular destination. Let's take a look at this. All right, now what I'll do is, let's see, I will grab my console here. Let me erase some of this stuff. And let's take a look at one of these other devices. Notice 21 has no information about stub or suppressing queries. Neither does 20. So let's go ahead and re-enable our debug. Debug, packet. And what I want to do is I'm going to go back over to R22 and I'm going to no-shut this interface. Now keep in mind that no-shutting the interface means I'm going to start sending information out, which means I'm going to send updates. Notice here we're sending an update. We received an update. Let's see. Where am I looking at? Queuing update. We sent it to R2. We should have also sent it to R1. Did I leave that interface down? Let me double check something. I'm sorry, R2 and R3. So do show, actually, I think I turned it off over on R2. No delay. Do show IP interface brief. Exclude assigned. Okay, nothing's down there. Do show IP EIGRP neighbors. We only have the neighborship with the one, so do show IP interface brief. Exclude assigned. Link is down here. So that's going to 2. Do show IP interface brief. E assigned. Now I've got an interface down on 2. Let's take a look at 3. Oh, there it is. No shut. Sorry, my mistake. This should bring us back up. We should start sending the updates out. Yep, there we go. We're sending an update out to 1 now. So that's going over to R3. So what I'm going to do is let's go over to R5 and see what happened. Let me go ahead and delete that. R5. Notice that we received information, and we sent an update out tunnel 0. Three different times. So we got tunnel 0 and tunnel 0. Well, there we received an acknowledgement back. All right, so what I want to do now is I'm going to go back over to R22 and I'm going to shut that interface down. I'm going to say shut. And that's going to, again, force that whole propagation process until we reach R5. Now, when we reach R5, let's see what we have. Okay. Enqueuing update on TU for neighbor 10.10.10.19. Let's see, do we see anything else in here? Let me do something here. Let me do a show log and see if all this is getting captured, which it is. And what I want to see is I want to show log pipe include tunnel 0. TU0. Well, let's see what's going on. Well, we enqueued an update on tunnel 0 on TU, and let's see what we have. We have, let's do this. I'm going to clear logging, show log. Nothing. Okay, so let's cut over to R2, R22, bring that back up to say no shut. That's going to force an update. There it is. All right, clear logging, show log. All right, log's clear. Now we'll go back over to R2 and bring that interface back up. No shut. Now this should force R5 to ultimately send some queries, or send some, actually, no, I need to, what did I do? No shut. Shut. That should send it out. We should see R5. Let's go over to R5 and let's take a look and see what's going on. Show log. And let's take a look and see what we got here. Well, notice we're sending a query to 10.10.20. All right, let's come up here and see if we're sending anything else. I'm looking for tunnel 0 specifically. There's 21. Let's see, do we see 19 in this list anywhere? Let's do this. Show log pipe include TU0 and query. Now we received an acknowledgement. We sent an update to 19. But what we're going to see here is we have no queries that we're sending to 19. Why? Because the flag was turned off. Well, what I'm going to do, just to wrap this up, I'm going to go over to R22 and bring that interface back up. No shut. And we'll configure the summary or the stub on 20 and 21. So on R20, EIGRP stub. And on 21, router EIGRP. Now remember, 21 is running named mode. So named, address family, IPv4, unicast, autonomous system 10. And let's see, can I use EIGRP stub here? Yes, I can. And notice I have the same features in named mode that I had it before. So we'll do stubbed. I'm going to go to R5 and I'm going to clear IP EIGRP neighbors. Wait for everything to come back up. Now it's going to toggle all kinds of output. We'll wait for everything to or show IP EIGRP neighbors. And as you can see, we got lots of information being exchanged here. So I've got 19, 20, 21. So everything should be stable now. So I'm going to say clear logging or clear log. Now what am I going to do? I'm going to go over to R22 and I'm going to shut this interface down. Now keep in mind that's going to have R22 send it to 2 and 3. 2 and 3 is going to send it down to R1. Ultimately it's going to arrive on R5, which is our hub, and we can see that it arrives. And now let's take a look and see what we got going on here. Notice that we're sending, we've got acknowledgments, but do we have any queries? Let's do this. Show log. We received acknowledgments. We sent updates. But the question is did we send any queries? Well, there we got queries. See what's going on here. Show log type include query. Okay, now we're sending a query on Ethernet 01, Ethernet 00. We enqueued a query on TU0, and we sent a query on only Ethernet 00. So we didn't send a query on Ethernet 01. Let's take a look and see what we got here. Let's say show log include, let's see, TU0. Let's see what we got here. We enqueued a query, so there it is. But did we actually send the query? Sending an update, but we didn't send the query. And the reason that we didn't send the query, again, is this idea of show IP EIGRP interface detail. Oh, I'm sorry. Let's see. Is that what I wanted to do? No, I wanted to say show IP EIGRP neighbors detail. And the reason that we didn't send them is because now we see that our stub peer advertising, the stub flag is set on each of those individual devices. Now, it didn't affect the interfaces going out towards, say, R4, but it only affected the interfaces that are participating in our DMVPN configuration. Now, the key element here is, again, this is going to give me the ability to be able to do filtering. So what happens if I go to one of these devices? Let's just arbitrarily pick one. Let's say R19. And I want to change its behavior. Well, it's sending summary and connected by default. But what happens if I don't want to send connected? Well, could I go EIGRP stub and say specifically what type of prefix I want to advertise? Well, let's say just summary. And we'll modify that. That should cause our adjacency to bounce, which it has. Now what I want to do is cut back over to R5 and let's look at the details. Let's go say you all, turn the debug off. And let's look at the details of the show IP EIGRP neighbors detail command. Now what I want you to see here is notice our stub peer advertising is still on, but notice we're only advertising summary routes. So this is saying that R19 is only sending me summaries. It's not sending me any of my more specific prefixes. So the question now is if I go over to R2, do you all, and type show IP route, and I want to look at 172.16.19.0.255.255.255.0 and hit enter, it's not going to be in my routing table. What about 20? There it is. Can I reach it? Ping 172.16.19.19. I don't have reachability. And the reason I don't have reachability is I specifically told the stub router to not advertise its connected interfaces. It's only advertising summaries. Well, let's go over to R19 and let's see what happens if we generate a summary. So what we'll do is this. We'll go over to R19, and what I will do is I'm going to say interface tunnel 0. IP summary address, EIGRP 10, and the summary that I want to advertise is going to be 172.16.19.0.255, actually I'll just use this /24. So I'm now generating a summary. Now when we look at this, this is going to cause my tunnel to resync, but we're generating a summary that's 172.16.19.0/24. So now let's go over to R22 and see what we find. Show IP route for 172.16.19.0. It's not in my routing table. Well, let's do this. See, is there a show IP route 172.16.19? I'm not seeing anything. Let's see if we advertise the right prefix. So we did 172.16.19/24. So is that even being learned at all? Let's go to R5. Show IP route. Notice I'm not learning it at all. I've got 20, I've got 21, but I thought that we could advertise a summary prefix. Let's go over to R19 and take a look. Do show run, interface tunnel 0. Now what we see here is IP summary address EIGRP 10 172.16.19.0. We're generating it. It's on tunnel 0, and do show run section router EIGRP is going to tell me that I am EIGRP stub summary. Let's take a look at that. Router EIGRP 10 EIGRP stub, and the summary says do advertise summary routes. So let's see, do we have a summary route? Do show IP route on this device. Let's take a look and see what we have. We should have 1 to null 0 if we got our sums right. Let's see, show IP route include null 0. So I'm not seeing anything here. Am I actually generating a summary? Show IP route include summary. Do show. No. Do show run. I am generating a /24, but the question is that a summary? Is there a longer prefix in my table? Let's take a look and see what we got going on here. Exit, exit, show IP route 172.16.19.0. Notice it says it's directly connected, and it says it's a /24 already. So I'm not generating a summary. Now, the question is how can I modify that behavior? Well, let's do this. Let's say config T. Let's go to the interface, or to the interface, tunnel 0. Let's get rid of the summary that we have. No IP summary address, EIGRP /24, because remember, it is a /24. Let's just change this to a /23. See what happens. See if it screams at us. All right, so we want to, don't do the no. Let's go ahead and do the IP. Show IP route. See what we have going on here. Now notice we have a null 0. We didn't summarize it. You can't just create a summary and match the existing network mask and expect the routing protocol to generate a summary. Why? Because we have a more specific. We have the connected interface. And remember, we had this idea of whether or not these prefixes are going to be believable. So let's go over to R2 now, and let's take a look and see what we have in our table. And now what we're going to see is that we have a 172.16.19.0. Now what would happen if I did what I've been doing? 255.255.255.0. Notice it's not going to show up in my routing table. But what if I came up here and said 254.0? There it is. So when you use this filter, be mindful of exactly what you're trying to accomplish with it. If you specify that you want to see a /24 and there's not a /24 in your routing table, it's not going to show. So a lot of students just simply use the show IP route and the network, and it's going to match the criteria. I could, and I like to be a little bit more specific, again, because I'm trying to zero in on specific details inside of a topology. And now what I want to do is I want to see if I have reachability to that prefix. Let's say ping 172.16.19.19, and we see that I have reachability. I can even trace route 172.16.19.19, and we see that we're going to go to R3, to Cat2, to R5, from R5 straight to 19, out the tunnel interface. So we've seen everything that we need to be able to see with regard to doing the base manipulations. But what happens if I create a series of interfaces, go back to my normal mode of operation, whereby I want to be selective? No, actually, no, let's not even do that. We'll stay right where we are for the time being, because there's one other thing that I want to be able to specify. What I'm going to do is I'm going to go back to R19, and I'm going to remove the configuration. I'm going to say config T, router, EIGRP 10, and I'm going to remove my summary, or remove my stub config. No EIGRP stub, do show run section router. Okay, I'm going to say EIGRP stub, which is going to, again, allow me to advertise my connecteds, and it's going to allow me to advertise my summaries. I want to get rid of that summary command. So interface tunnel 0, do show run interface tunnel 0. And I want to get rid of my summary. So let's get rid of that. So we'll say no IP summary EIGRP. Let's repeat the show command to make sure it's gone, and it is. So now if I go over to R5 and I execute my show IP EIGRP neighbors, everything should be connected and summary. Connected and summary, connected and summary. Oh, wrong neighbor. Connected and summary, connected and summary, connected and summary. So we have all three of them. So now I should have reachability. So let's see what's going on. So ping 172.16.19.19, .20.20, and 21.21. And we have reachability. And we should have all of the entries. Show IP route in our routing table. So here they are. We have 20, 21, and 19. So everything's good to go here. Now what I wanted to illustrate is what happens if I say I only want to receive updates. Let's look at that. So now I'm going to go to R19, and I'm going to say EIGRP, router, EIGRP 10, and I'm going to say that I want to have a stub, or EIGRP stub, and I'm going to use receive only. Let's take a look at that. So if I say receive only, what this is going to mean is that I'm going to learn prefixes, but I'm no longer going to advertise prefixes. And again, it's going to cause my adjacency to, oops, didn't mean to do that, sorry. I'm going to cause my adjacency to bounce. So we'll form a new adjacency. So on R22, let's see what we have. Show IP route 172.16.20.0, 21.0, 19.0. Not in my routing table. Oops, 19.0. Not in my routing table. So, do I have reachability? Ping 192.168, sorry, 172.16, 21.21, 20.20, and 19.19 should fail. Now, the interesting component here is that when I go over to 19 end, show IP route, what do I see? I see all of my prefixes. Ping 172.16.222.222. Actually, that's not a live prefix. I think I turned that off. Let me double check something. Show IP interface brief, E assigned. Yep, there it is. It's administratively down. Config T, interface LO100, no shut. Do show run section router, and it should be being advertised. So now if I go to 19, I should be able to hit it, which I can. I should be able to hit 2.2, I'm sorry, 1.1, 2.2, 3.3, 4.4, and 5.5. But what happens when I source any of these from my own loopback address? So loopback 0. IP ping source LO0. Notice I now no longer have reachability. Why? Because I'm not telling anybody about my connected interface. Now I may want to change that behavior, and that's what we're going to entertain next. I'm going to use my loopback, I'm going to use my loopback, and I'm going to advertise my loopback even though I said I do not want to do anything. I just want to do receive only, but I'm going to have to make some changes. What I'll do is I'll go ahead and just create this as a regular stub, and I'm going to say only advertise summary prefixes. And we'll look at it once more in the next video. And with that being said, that wraps up this part of our presentations, and I'll see you guys in the other presentation. Bye-bye.